and more longer lasting than the ones which deal with a large conglomerate of technologies. And at some point of time I get into trouble that one of the companies which was providing that particular technology is dead, and I am stuck. Or one of the other products which is helping me with one aspect of my solution is lagging behind in terms of evolution, so I have to enhance his product. So rather than getting into those complexities, I would stick with some of the proven technologies and a few of them, and build my business solution. That may require me to do a lot of work towards integrating those technologies, but that's what will become my USP, right? Okay. So if it is a pure plain integration of available open source technologies or available commercial technologies that anybody can do, but if I want to differentiate myself, then I have to add value to it, and that's where I think the niche lies for a startup.
Hold on a second.
Especially in terms of the future of big data, I was a bit surprised that none of you actually talked about the emergence of artificial intelligence and from machine learning to deep learning and some of that as the future. So any thoughts or comments on it would be welcome. Thank you.
With respect to SAP, after SAP HANA was full-fledged with 1,000 odd customers, we felt that the big data space will be more utilized when it is combined with IoT, Internet of Things. So when we started analyzing IoT, what we felt was the source for the big data could be coming from some kind of sensors, mobiles, social media. So the source is many. So what will be the future? What will be the future? In the next 10 years, you will find a number of companies evolving as IoT connectors, which will be able to connect to appliances, pick up signals or sensor data, and convert them into formats that are database specific. For example, what could be, you cannot consume a signal and plot a graph. So if you want to monitor signals over a period of 1 year from a particular device and then plot a graph out of it, now that becomes the source. The connector becomes the translator, which has to talk to all kinds of protocols and all the connectivity to the platforms. And then you already have mature platforms which are there, whether it is SAP or any other, you have mature platforms. So these platforms would be cloud enabled. They would be able to process millions and millions or billions of data records, and definitely in order to cater to this kind of data, we need the sophisticated UI that could be the best of the user experience to plot or to show this data in an appealing manner to the user to make decisions. So three spaces where the industry is going to grow is IoT connectors, UI, as well as platform which is cloud enabled. So this is where I see the future.
If I may add, I think his question was relevant to machine learning as well. I think there's going to be a hell of a lot of emphasis on Mahout, or even the Spark ecosystem has got machine learning algorithms that are getting built on top of it. So I think you're going to see things like automated cars and stuff like that, where machine learning is going to be a very central component, if I may add to what Krishna has just mentioned. We'll move on to probably one. Do we have time? Probably two questions.
Please,
okay.
Right. So, what are the best practices we can leverage from what we have learned and what mistakes we've done in past, so that we don't do that with Hadoop?
Sure. I think I can take that question. It typically falls under the EDW. I think you come from the EDW data mart background. One of the often left out components of a big data and Hadoop ecosystem is data integration. When you have data from source A and you have data from source B, a lot of times you'll have to normalize the data. You'll have to say the source that we are getting from here is the better source when compared to the source that you're getting from there. These patterns are a commonly solved problem. You're talking about master data, you're talking about integration layer, be it a ODS or a EDW ecosystem and so on and so forth. They are not going to go away. In fact, Ralph Kimball has a beautiful presentation, which I'll probably allude to and encourage you to take a look at in Cloudera's website, where he talks about the ecosystem, the Hadoop and the big data ecosystem playing host with a traditional EDW data martish flavor. And one of the things we are doing in Altisource is also that we are using data lake as the staging layer, where we are going to do it as a sink, where data comes and sinks into the staging layer. And then we will have to feed, for the traditional businesses, we will have to create data marts, we will have to create data, EDW layers, ODS layers on top of it. So the answer to your question, madam, is that I do not think, at least personally from my viewpoint and whatever I've come through, I do not think the Hadoop ecosystem is going to replace EDW and data mart paradigms, whether it is going to play host in a slightly different way. The staging layers are going to change. They are going to disrupt the staging layer, but the integration layer will have to be there. You will have to have technologies that will read from Hadoop, build be it a 3NF or a dimension model, whatever it is, you will have to build them. So, that's how we are approaching it, at least from our perspective. Any other question? One last question, maybe. Yeah, please.
Say already Facebook and bigger companies like LinkedIn, Facebook, Yahoo, they tried over petascale.
Yeah.
So they did a lot of batch processing with Hadoop. Another one is its vibrant community. So there are hundreds of committers are there. They are continuously working over all the bugs and everything. So that is one more thing. Another one is cost. So compared to other technologies, this is like whatever HDFS is offering, like you can store petabytes data with in over commodity hardware. Like with that one, you can reduce massive cost.
Sure, absolutely. I think you're probably nailing down the point that Hadoop is moving towards an infrastructure. Just like infrastructure as a service. You're talking about platform as a service, and then you're moving software as a service. I see the HDFS component of it playing the infrastructure. In fact, when Spark comes into the ecosystem, you're going to get compute grid for free. Like almost for free. They are all going to play into the infrastructure layer. That's a way, at least, I would like to look at the Hadoop ecosystem. There are a lot of stacks, there are a lot of tools that are going to be built on top of it, but the infrastructure is the key here. Now, I think we are running out of time. So I would like to conclude this with one question here to the panelists. A lot of Hadoop enthusiasts are here, and a lot of people want to be into the Hadoop big data ecosystem. What would be your one or two suggestions in terms of the challenges that they will face and how they should avoid some of the key learnings that you would have come across in your experience? Maybe I would like to leave that as your concluding thought, so that it's more of an advice for the audience here, leveraging your experiences. Can I start with any one of you?
You want to talk about my mistakes? Well, I think most of the time, one of the mistakes I was doing very, very often, especially when starting some new exciting projects, was trying to use too much of the new technology at the same time. So if you are facing new project, try not to pick up too many new technologies. Like 1, 2, I would say is probably the maximum, because you have probably lots of problems, especially if it's not a mature technology. If you're going to choose 5 or 6, you're asking for trouble.
We'll probably restrict it to one challenge. We're really running out of time here. So,
okay, yeah. In fact, well, I would like to change a little bit. I want just to say that you don't have to think that Hadoop. So basically, you have to think about your use case and really analyze if Hadoop is a solution for your use case. Not first putting the Hadoop there, and then I will try to adapt my use case and what I want to do to this technology. Is the opposite. You have a use case, you have something that you want to solve, and Hadoop might be a solution, but it comes later. So that is what I want to say.
Yeah. So I'll point to my experience related to one of the points which Professor Dinesh made about the data quality. So data quality is one major concern. So the data which arrives to us, unless it is coming from an authentic source like a bank's database or a point of sale database, if it's coming from places like Facebook or Tweet or even Wikipedia, the authenticity needs to be questioned before we actually put our analytics or Hadoop engines on it. So that is very important. Otherwise, we'll end up with saying that a Bollywood movie is most popular in Peru. So those kind of results will come out. And one quick other thing I want to point out from my experience is when we were trying to build up a solution based on Hadoop ecosystem, we spent quite a bit of time trying to set it up in our local premises environment, and things kept on failing. We had to procure systems and all that. And later on, after performing that exercise successfully, when I was looking at AWS, they have offered this EMR service, Elastic Map Reduce service, which takes away all the headache of adopting Hadoop-based solution. So you just have to do a quick configuration. I mean, what they claim is like in 15 minutes you can have a Hadoop cluster ready for processing your business analytics. So adopting cloud for big data solutions is, I think, something we should consider.
One point which I would like to make is, with the advent of all this, the way in which we design applications, everywhere you see designs which are aiming at real time. Everything needs to be real time. This is the perception. Everything need not be real time. Near time is also good enough. A few seconds of delay sometimes is good for an application design than have a real time system which can break at any time. So big data has advantages, but we also need to look at where it suits the business. Not everything needs to be real-time applications. So we need to use the right application of big data for the right business. So that's where intelligent decisions can be made out of data. So that's the message I would like to give.
Thank you for that. My concluding thoughts would be big data is all about technology. All about technology, it's a good thing, but do not ignore people part of it. People, process are very, very much important. You are actually setting up, entering into a completely new ecosystem. So the DBA, traditional DBA admins that you have in a, Oracle world is going to be different from a, Hadoop Spark world. So the processes around it, the people, the skills, the soft aspects of it are not spoken very often, but I would like to place a lot of emphasis on that particular, aspect of it. Thank you.
All right, we would like to thank all the panelists and, of course, Narendran for moderating the panel discussion so well. And at the same time, we would like to thank the audience for being so interactive. With that said, we would like to issue certificates to all our panelists. So to start off with, can I have Narendran? Radhik? Antonia? And Mr. Krishna Kumar. Yep. Yeah. So let's break for tea and perhaps, yeah. Oh, I'm sorry, I missed out on Mr. Amit Jain. So sorry. Yeah. Yeah, so let's break for tea and reassemble at 11:30. After which it's going to be a free foot since we are, the entire session is going to split into two tracks. We're going to have a technology track which is going to happen right here, followed by the analytics track at the neighboring auditorium. So you can feel free to opt for any track of your choice. Yep, thank you. For Data Mine Lab, over to you.
Thank you very much. So first of all, let me ask if everyone hears me very well. Yeah, no problems? Okay. So, hi, my name is Radek, and I'll be talking about the data stream algorithms in Storm and R. So before I will introduce myself, actually, let me ask who here uses Storm? Okay, great. And R? Wow, excellent. So, it would be much easier to explain everything in details. So my name is Radek. I'm doing consulting at Data Mine Lab, a company which is focusing on data mining, business intelligence, and data warehouse. I work as a data scientist contractor at MCM. It's one of the biggest hedge funds in the world. My background is kind of all over the place. I have 3 degrees, bachelor in computer science, master's in cognitive and decision sciences, and master's in bioinformatics. So as you can imagine, it's very far from computer science, most of it, and definitely from finance. And during my career, I worked with many companies on big data projects and real-time analytics projects. I listed some of them in here. So the agenda for this talk is we start from just looking at the streaming data and trying to understand why would we want to use the streaming data in the first place. Then I will give a quick crash course in a couple of streaming algorithms. It will be a bit technical, but shouldn't be too difficult. Then I will give you a quick introduction to Storm for those of you who never heard about this or don't know much about it. And then we have a look at how to integrate both Storm and R together on your projects. And during the presentation, I will also give you a few use cases so you have some reference to how to actually use it in real life. No. I mean, sorry, but I never actually used Spark in like a real project. So, I prefer not to say too much about it. You probably know more about Spark than I do. I can tell you, I will focus mostly on the Storm, but we can have maybe some discussion after the session and share the ideas. So why would we want to use the data streaming in the first place? Well, there's a recent report published by IDC back in 2012, which estimates the data growth in future. So as we can see on this graph, by 2020, we can expect that there will be about 40,000 exabytes of data produced every year. 1 exabyte is 1,000 petabytes. So as you can see, this number is quite significant. But as you can see on this diagram, there is quite a huge discrepancy between the amount of data which is actually being produced and the amount of data that we can physically store on the hard drives. So this is one first good reason for using data streaming, because we cannot technically even store all the data on the hard drive. So what can we do with it? Well, we can throw it out, obviously. But instead of just simply throwing out, we can apply some data streaming to this data first, which will allow us to extract from this data only the information that is interested to us and store that interesting information. So this way, we don't have a choice. We will have to use something like data streaming in the future simply because we cannot store all of this data. So, for example, in 2013, we were only able to store about 33% of all the data globally being produced. And we can expect that this difference will be even bigger. By 2020, we'll be able probably to store about 15% of the data. So the second reason why would you want to use the data streaming is to do the real-time computations. This is usually the first reason people give. And well, the reason why data streaming is so fast is because, well, the data is never really written to the hard drive. Excuse me. So the data flows through the system, is analyzed in memory and CPU and the network. And because of this, we can do very, very fast, near real-time processing on that data. The third reason why would we want to use data streams is the scalability and the cloud processing. So we are talking here about big data technologies, and the common feature between the big data technologies is that it's scalable, meaning you can put it somewhere on the cluster, and you can analyze your algorithm once you write it, whether it will be 1 terabyte of data or 100 terabytes of data. Your algorithm should scale to pretty much any amount of input data stream. Few examples of the data streaming algorithms. Network traffic. It's a type of the data that doesn't really bring a lot of value. So you do not really want to store all of the data traffic that is being exchanged in the internet. But at the same time, you want to usually extract some interesting information from the network traffic. Web traffic is quite similar, especially online advertising. So again, nowadays the online advertising has a pretty small value. So very often it doesn't make a business sense to kind of spend thousands and thousands of dollars to store all of your data. You might want to just extract only the information that you want, only that is interesting to you, and throw out everything else. And when it comes to real-time data processing, fraud detection is a very good example.